Hi everybody. So in today's lesson we're going to look at these problems that deal with modeling with sinusoidal functions. Modeling with sinusoidal functions. It's basically taking a real life word problem and converting it into a sinusoidal function. Okay, so it's a real life example that can be modeled using a sinusoidal function. So let's see how we do it, all right? All right, so we have this problem. Okay, we're given Valeria is playing with her accordion. The length of the accordion, A of t, it's in centimeters, after she starts playing as a function of time t in seconds, can be modeled by a sinusoidal expression of the form A times cosine B times t plus t. And it says at t0, when she starts playing, the accordion is 15 centimeters long, which is the shortest it gets 1.5 seconds later. 1.5 seconds later, the accordion is at an average length of 21 centimeters. Find A of t. T should be in radians. Okay, so the first thing we want to look at is, okay, what's the important information here? So let's kind of pinpoint that. I'm going to select blue, and I'm going to kind of try to see what's important here. Well, definitely it says here that A of t is in centimeters. Okay, that seems pretty important right there. T is in seconds. And then we're given this function A times cosine of B times t plus t. And here at t0, so this is the initial point, she starts playing the accordion. It's 15 centimeters long, which is the shortest it gets. So since it's the shortest, my guess is that we're starting at the min. Okay, shortest means min. 1.5 seconds later, the accordion is at the average length. So here at 1.5 seconds, the length is 21 centimeters. Okay, so the question is this then: how can we dissect the information here that's important? All right, so I'm just going to kind of copy this over here. So we have the function, okay, I believe it said, okay, yeah. So we have the function A is equal to, oops, sorry. We have A cosine of B times t. It's not x because now the variable is t, and then plus d. Okay, here's our function. And this function is in terms of t, right? Because it's time. And we're given some information that says, let me just pull it over here. Okay, we have t0 at t0, so f at 0, so the function at 0 is 15. Okay, hold on. And this is 15 centimeters, and it's saying this is the shortest, so it is at its min. Okay, so it starts at 0. And then it tells you that at 1.5 seconds, so at f of 1.5 seconds, okay, it's saying now it's at the average length, which is 21 centimeters. So we're at 21 centimeters, and they're saying this is the average. Okay. Okay, guys. So if I were to kind of look at this, this thing goes from minimum to average, correct? So if I had to do like a quick sketch, okay, so this function, it starts at the minimum, which is at 15 centimeters. So this is at 15 centimeters here. So this function starts at 15. Change the color. It starts at 15, and then it's going to go, starts at the minimum 15, and then it's going to hit the average at 21. So let me just change it back. It's going to hit 21. All right, so this function kind of looks like this. It's going to go like this, and then it's going to hit the average like that. Like that, okay? Starts at 15 at t equals 0. This is 0, right? T is equal to 0. And here is 0. And then at 1.5, this is 1.5, it hits 21. Okay, so definitely we know that this thing, okay, this thing's going to keep going like this because it's sinusoidal. So it's going to keep going up, and then it's going to do this. It's going to turn around, come back down, etc., etc., right? It's going to come back like that. All right, so we're now definitely going to need amplitude, frequency, and midline, correct? If you look here, we're already given the midline. There's your D, correct? And this, of course, is your minimum value. So we can easily find what the amplitude is here, right? Because we know that the amplitude is just the distance right here. That's your amplitude right there. It's a distance from the midline to the min, or midline to the max, right? So amplitude is the difference of 2115. So our amplitude is going to be what? 6. There we go. And D is already given. That's the midline. That's the average value. So we have our 21. Now we need to find a frequency, B, correct? In order to find it, we have to take 2 pi divided by the period. Well, period from the minimum to the midline, that's 1.5, is it not? This distance here is 1.5. But we know that this distance is only going to be a fourth, right? Here's a fourth. That's a fourth right there, correct? There's a fourth right here. And then the final fourth is going to come right here, correct? There's a full period. That's one full curve. So a fourth, a fourth, a fourth, and then another fourth, right? Sorry, it's not evenly spaced. So we know the period then is just 4 times 1.4. So it's 2 pi over, it's 4 times 1.5, sorry. All right, and of course that is 2 pi over, this is 4, 6, which can be reduced to pi over 3. So I think we are ready now to write our function, correct? So our function f of t is equal to a 6 cosine. Now remember, cosine normally starts at the max. This is starting at the minimum, so we have to put a negative in front, right? Cosine is starting at the min. So cosine must be negative. So it's negative cosine, right? So negative 6 cosine. And then, of course, we have our b of t. b is pi over 3t, okay, plus 21, which is our midline. I think that is our final answer. Okay, so let's quickly check it. Let's go over, and then we'll type it in and see. Okay, negative 6. So negative 6 cosine. And then we're going to have pi over 3. Pi over 3. And then it's t. Variable is t. Be careful with the variable. And then plus 21. 21 was our midline. Let me just quickly check. Yes. So I think we have it. Let's go like that, and then and that is correct. Okay. All right.